Okay, section 4.2. In section 4.1, we talked about bias in samples, how to mess up samples, in other words. Today we're going to talk about the ways to do good samples, basically, how to do them, or at least that aren't biased. They might not be representative, like talked about, but at least not be biased. So there's multiple ways to do this. The main idea, and I said this in the last one, is that every person must have the same chance of being picked. But there's more to it than that. Samples must be random, first of all. Okay, so we're gonna start by saying choosing a sample by chance is the only method that's guaranteed to be unbiased. Okay, so you have to use some sort of probability, but there's lots of different ways to do that. All right, the first and most common way, but not the easiest, is what's called a simple random sample. You're going to hear me use this terminology all year long. We're going to use this terminology SRS. Anytime you see SRS, it means simple random sample. A simple random sample has a definition, which I'm going to give you in a second, but also I'm going to tell you a little bit about it. But in a simple random sample, actually, this is a definition. So let me start by saying that. Let me just put it. All possible samples of a given fixed size are equally likely. So let's say you're going to try to pick 100 people from Mountain View High School. I'll keep using that. So we break it up into freshmen, sophomores, juniors, seniors, males, females. It's kind of easy to do that. So let's say you want to take a sample of 100 people. So you must guarantee that all groups of 100, so if you think about 2,000 people at Mountain View High School, 100 sample size. So if you do 2,000, choose 100 on your calculator, it's going to be gigantic, whatever it is. Every one of those possible samples has to have the same chance of being picked. Okay, that's what's called a simple random sample. In a simple random sample, it is true that every person will have the same chance of being picked, and every two people will have the same chance of being picked, and every triple, all the way up to all 100. But really all we care about is what's in that red box. Okay, because if every possible sample of a given fixed size is equally likely, then we meet all those other requirements. But if all we want to do is meet this requirement, like say that first one, there are other ways to do that that aren't simple random samples, which I'll show you in a second. All right. So as I go through the other types of samples that are still good samples, they're just not simple random samples, we don't meet that requirement that all possible samples of a given fixed size. So there's really only two ways in our world to do a simple random sample. They're like giving everyone a number and using a random number generator, or using your calculator to find an integers or something like that, or just putting all the names in a hat. Those are really, in our world, the only way to do simple random samples. We'll talk a little bit more about putting names in a hat as we go through the course and how we phrase that, but those are really the only ways to do what are called a simple random sample. Everyone has the same chance of being picked, but more importantly, every possible sample of a given size. And here's what I mean by that. We could take, check this out. I could look at my class roll, okay, and say, I want to pick 5 people. And the way I'm going to do it really easily is I'm going to pick just a chunk of 5. It's either the first 5, the second 5, the third 5, the fourth 5, the fifth 5, or the sixth 5. Just really quick and easy for me to do. So I'm going to maybe pick a number from 1 through 6. And if it's 3, I'm going to go to the third group of 5. Okay, really easy. I got 5 people. Everyone had the same chance of being picked, believe it or not. Sometimes people don't believe that. I'm picking 5 people out of my class, out of, let's say, 30 in the class. So it's 1/6. Everyone has that same chance of being picked. However, not every group of 5, because every group of 5 means 30 choose 5, all of those groups. But if I'm only going to possibly pick those chunks, if your name starts with B and someone else's name starts with R, you can never be picked together in my method. It's not really a problem. It just makes it not a simple random sample, because not every group of size 5 has the same chance of being picked. So if someone ever asks you why it's not a simple random sample, you simply need to say, because not every group of size X, whatever it is in that problem, has the same chance of being picked. Okay? So there are other types of samples that are just as good, sometimes quicker and easier. Simple random samples are kind of a pain. You got to put all the names in a hat. You can see how fast my little model was. If I just wanted to pick 35 people in my class of 30, how fast that was, just to pick a number 1 through 6 and go to that group of 5. It's a lot easier than giving everyone a number or putting all the names in a hat. So the first other type is called I'm just going to give you 4 types today, explain what they are. That's it. It's pretty straightforward. First one's called a stratified random sample. Stratified random sample. We don't call that SRS because that's simple random sample. A stratified sample is when you divide people into groups. I just did that, right, with my groups of 5, 5, 5, 5, 5. You might separate freshmen, sophomores, juniors, and seniors. You might say, instead of picking 100 people at random, I'm going to pick 25 freshmen, 25 sophomores, 25 juniors, 25 seniors. So you divide them into groups. Those groups, I just like to call them groups. The book calls them strata. I don't like that because in the next one, they're going to call those groups something else. They're just groups. They're just groups. And then you just pick a simple random sample from each strata. So in other words, I group freshmen, sophomores, juniors, and seniors and take 25 of each. That's a stratified random sample. I separate males and females and take 50 of each. Boom, done. Okay, those are all stratified random samples. Notice I separated and then I picked some from each one of those groups. Okay, why might we do this? So convenience is just quicker. Like you can group people quicker. It's a little bit quicker. It's not super quick. This is the big one though. This is the one I would say is the most recent. It ensures coverage. So let's say I did that example where I put 100 names from the school in a hat and I picked 100 female seniors. Boom, I didn't make sure I got freshmen and sophomores and juniors. Maybe it matters, maybe it doesn't matter. Like again, if I'm doing classes, maybe it doesn't matter. But if it matters, you ensure that coverage by splitting up and you make sure you get 25 of each. You're making sure you get a representative sample. So remember, you can do a sample the right way and it might not wind up being representative of the population. This kind of ensures that. A little bit. The third one is it reduces variability. You don't wind up with people all spread out all over the place. You might get them more together, so it can reduce variability a little bit. But the most important one is that coverage. Okay. The next one is called a cluster sample. You're going to start a cluster sample the same way. You're going to break them into groups. They call them clusters now. It's kind of silly. Stratified, strata, clusters, but they're just groups. You break them into groups. Then remember in the stratified, you take some from each group, but now you're not going to do that. First of all, you're going to take a simple random sample of the groups. So in other words, let's say I'm in a classroom and I group you by those 5s, right? I go group 1, group 2, group 3, group 4, group 5, group 6. And then I want to pick, let's say, a certain amount of people. Maybe I've just picked 2 of those groups first. Then once I've broken the groups down, now I've picked 2 of the groups. Once you pick the 2 groups, then you get everyone data in that group. So my example of the roll sheet, it was a cluster sample. Broke them up into groups of 5 and picked 1 group and then asked everyone in that group. Okay, the key is I ask everyone in the group because the next sample is going to sound very similar, but it's a little different. It's called two-stage sampling. We're going to break them into groups, same way. We're going to pick a simple random sample of group, same way we just did. But then instead of asking everyone in the group, then we're going to take a simple random sample from the groups we chose. So in other words, let's say my population, I did this 1, 2, 3, 4, 5, 6, 7. Somehow I broke my population up into 10 groups. And then I randomly picked numbers 1 through 10, like 3 numbers. So I picked 3 numbers and I got this group, and that group. Okay. Now, if I was doing a cluster sample, I'd ask everyone in those 3 groups. However, if I'm doing a 2-stage sample, I just grab like 5 people from here now and 5 people from here and 5 people from here. So it's just kind of dwindling it down a little bit. That's called a 2-stage sample. So there's one more, but I'm going to kind of write this a little bit. This might help you. I always do this. I think people like this. Stratified, cluster, 2-stage. So in every case, we're grouping, right? But in the stratified, we're taking some people in all groups. So we're taking some of the people in all of the groups. We're ensuring the coverage of all of the groups. In the cluster sample, we're taking all of the people in some of the groups. Now we're not taking all the groups, we're just taking some of the groups. And in the 2-stage, hopefully you know this one, we're taking some of the people in some of the groups. This sometimes helps people break it down a little bit. Last sample is a little different. Doesn't really meet this stage. It's pretty simple, though. You guys have done this all the time, I think. It's called systematic sample with a random start, or counting off. So you divide the groups into, divide people into groups just by counting off, and then you pick the groups. This might be like, just I'm sitting here in class looking here, I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. I just number you guys off and I take all the ones or something. I just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I give everyone a number and then pick person 1, person 11, person 21, person 31, something like that. Somehow we're divided just by counting off. I want to ask a bunch of people as you walk into the gym for an assembly, and I just take every 10th person. Everyone has the same chance of being picked in all of these things. However, none of them are simple random sample. Here's a really key thing, because not every group has the same chance of being picked. In other words, if I pick every 10th person walking into the gym, everyone has the same chance of being picked. However, if I'm walking in next to my buddy, we both can't be picked, right? Because we're not 10 apart. So we've eliminated some groupings. Not a big deal normally, for sure. Just know the terminology is that it's not a simple random sample. Doesn't mean it's bad, and it's a lot quicker. Think about how quick that is. As you come in, I just grab every 10th person rather than putting every name in a hat and having to pick them out or something like that. So those are our other types of samples. We'll talk about them a little bit more in class tomorrow. See ya.